Everyone, this is Rajashekar Janjarla. I'm an educator at Unacademy, and you can follow me on Unacademy Learning App where you can find my other courses as well. In this lecture, we are going to discuss about the Rivetted Gear Trains, which is a very important topic for the GATE examination. And please rate, review, and share the video, and also subscribe to Unacademy YouTube channel. Welcome again to Rivetted Gear Train. So, depending upon the different applications, we have to go for the different gear train system. So we are going to see the applications of Rivetted Gear Train system and also the properties of its motion. Okay, so let's see. So here in this figure you can find a Rivetted Gear Train system. So the definition of Rivetted Gear Train system is that when the axis of the first gear, which is the first driver, and the last gear, which is the last driven or the follower, are coaxial, which means the axis of the first gear, that is the first driver, and the axis of the last driven is going to be same. So in this figure you can find the gear 1 is the first driving gear and the gear 4 is the last driven gear. As you can observe from this figure, the axis of the gear 1 and gear 4 is same, right? And the shafts, that is gear 1 shaft and the gear 4 shaft, is coaxial shafts. So a riveted gear train is very similar to a compound gear train system, right? So in the definition about the compound gear train system, we have said that when there is the transmission of power and the motion will be takes place between the shafts where there are two or more gates on that shaft. Okay, so this is the definition for the compound gear train system, right? So in this, the riveted gear train system, you can find a shaft where we have two gates on it. So this riveted gear train is very similar to a compound gear train. Okay, they are both used where there is only a small space between the input and the output shaft, and large changes in speed or power are needed. So if you want to have that large changes in the speed or power, we can use the riveted gear train, and we can also use them when there is the space limitation. So when we have a little space in between the driven and the driver gears, we can go for the riveted gear train system. So let's examine the motion of each gear in this riveted gear train system in the next slide. So here in this figure we have the riveted gear train system with 4 gates, that is gear 1, gear 2, gear 3 and gear 4. As I said before, the first driving and the last driven have the same axis, shafts axis, they are coaxial shafts. Okay, so let's examine the motion. The first gear, the gear 1 is the first driving gear, therefore the motion starts here, and these two, the gear 1 and the gear 2, are the mating gates, right? Therefore, the velocity, the direction of the angular velocity of gear 1 and gear 2 will be in opposite, right? So, as you can see in this figure, we have the direction of velocity of the gear 1 is clockwise, and the direction of velocity of the gear 2 is anti-clockwise direction. They are opposite. And next we have the combination of gear 2 and gear 3, this one. Okay, so these two gates are mounted on a same shaft, right? Therefore the angular velocities of the gear 2 and the gear 3 will be same because they are mounted on a same shaft. They will rotate in the same direction, right? So the motion of the direction of angular velocity of these two is same. And here below we have the mating gates, gear 3 and gear 4, right? So the direction of angular velocity of gear 3 and gear 4 will be in opposite sense, right? So thus we see that in riveted gear train, the motion of the first gear and the last gear is like, which means the motion of the first gear, the direction of motion of the first gear and the direction of motion of the fourth gear, which is the last driven gear, is same. Okay, so this is the mechanism of the riveted gear train system. Now we are going to find the speed ratio on the train value for this riveted gear train system. Okay, so with this example we have found the exact motion of each gear in the riveted gear train system and what is the actual output of this riveted gear train system. Okay, so let's see. So before going to do that, before going to find the speed ratio or the train value, we have to find the notation for these 4 gears in that riveted gear train system. So let T1 is the number of teeth on gear 1 and R1 is the pitch circle radius of the gear 1, and N1 the speed of gear 1 in RPM, revolutions per minute, and we have T2, T3, T4 the number of teeth on the respective gates, gear 1, gear 2, gear 3 and gear 4, and R2, R3, R4 the pitch cycle radii of respective gates, and N2, N3, N4 are the speeds of respective gates in rotations per minute. Okay, so this is the notation I'm going to use for the calculation of the speed ratio and the drain value. Okay, so since the distance between the centers of the shafts of gear 1 and gear 2 as well as gear 3 and gear 4 is same. Okay, so because here in this figure these two shafts have the same axis and these two gears also have the same axis because they are mounted on a same shaft. Therefore, the center to center distance between the gear 4 and gear 3 and the center to center distance between the gear 1 and gear 2 is going to be same, and it is equals to the perpendicular distance between the two axes of the two shafts. Okay, this shaft and also this shaft. Here we have two shafts actually, but they are coaxial, therefore the direction is same. So the perpendicular distance between the gears 1 and 2 and 3 and 4 is equals to the perpendicular distance between the axis of the two shafts in this riveted gear train system. So we can say that R1 plus R2 equals to R3 plus R4. Okay, so this R1 plus R2 is the center to center distance between the gear 2 and gear 1, and R3 plus R4 is the center to center distance between the gear 4 and gear 3, which is the sum of their radius. Okay, pitch circle radius. So we have this condition for the riveted gear train system. So next we have the circular pitch or module of all the gears is assumed to be same. Okay, and therefore the number of teeth on each gear is directly proportional to its circumference or radius. Okay, if the module is same and the pitch circle or the circular pitch is same, therefore the value of the number of teeth is directly proportional to its circumference or radius. So with this condition we are going to derive the speed ratio and the train value. Here the circular pitch PC equals to 2 pi r by t, right? That is equals to pi m, where m is the module. So from this condition we have r equals to m into t by 2. Okay, so similarly we have r1 equals to mt1 by 2, r2 equals to mt2 by 2, and r3 equals to mt3 by 2, and r4 equals to mt4 by 2. So these are the conditions that are evolved for the 4 gates on that riveted gear train system. So from the radius relation, that is this relation, and this relation that we have just found from the center to center distances, we have replacing the value of the r1, r2, r3, r4 with in this equation with these values, we have m into t1 by 2 plus m into t2 by 2 plus m into t3 by 2 plus m into t4 by 2 equals to t1 plus t2 plus t2 equals to t3 plus t4, where the sum of the number of teeth on the gear 1 and gear 2 equals to the sum of the number of teeth on the gear 3 and gear 4. So this is the condition that we have obtained by assuming these values, that is module is constant for the 4 gears in riveted gear train system. Okay, so let's see. Here we have the speed ratio. We knew that the speed ratio is the product of driven tooth numbers by product of driving tooth numbers, right? So the product of driven members will be T2 and T4 are the driven one, which are these two, T2 and T4. So this is driven, which is driven by this one, and this one is driven, which is driven by the gear 1, that is first driving gear, right? So the product of these two will be T1 into T4, and the product of the driving gears will be T2 into T4, this one, and this one will be T1 into T3. So the speed ratio is the ratio of speed of the driving, the first driving to the speed of the last driven gear, that is N1 by N4, that is equals to T2 into T4 by T1 into T3. So this is the value for the speed ratio for the riveted gear train system. Okay, so this is the speed ratio and this is the condition for the riveted gear train system, and this is also the condition for the riveted gear train system. Okay, and thank you.